All right, Brandon Clayton, the algebra guy here, talking about, as you see on your screen, how to convert between measurement systems. And this is huge and very applicable, especially if you're a foreigner or know someone who's a foreigner. But even if you don't, you'll learn that all measurements are not the same across the world, and you need to know how to convert between the two. So let's look at some examples. First, we'll start with what we wanted to address by the end of this lesson. Make unit conversions in the US system. Yes, the US system has its own measurement system. So use mixed units of a measurement system in the US system. Make unit conversions in the metric system. Use mixed units of measurement in the metric system. Convert between US and metric, and convert between Fahrenheit and Celsius. See, these are all applicable. Here's science. That's gonna come up quite a bit. So let's get into it. So first of all, here's what the first piece that we'll work with. We'll convert in the US system. So you see length, some measurements, some weight conversion, some volume, and time. I'm going to pull those up more as we go through some problems. I don't need to read this because I know you can read all that. But this is what we call the US system. Feet, yard, miles. Only the US, to my knowledge, is the one who came up with this and uses this for the majority. The rest of the world sticks with metric, which we'll talk about in the latter half, how to go between these systems and metric systems. So let's do it. All right, how do we do this? Select the measurement to be converted by 1. Write 1 as a fraction related to the units given and the units needed. Multiply, simplify the fraction. That sounds confusing. So let's just go ahead and jump right into it and show you what I mean. Mary Ann is 66 inches tall. What is her height in feet? So we want to convert. So here's the typical way you're going to think about converting. We're going to start with what we have, right? 66 inches. And we want to convert this. So to convert this, we need to start asking ourselves, how do we get from one unit to the other? So we want to get to feet. So I already know that 66 inches is what I'm starting with. Now I make the inches on the bottom and I want feet on the top because the units that I want to finish off with will be on the top. I know that there's 12 inches in every foot. And now this is the equation I have in order to get what I need. So I need to do 66 times 1 and divide it by 12. So let's do that. How many feet is that? Let's get my calculator out. And we'll do, what do we say? 66 divided by 12 is 5.5. So we now know that Miss Mary here is 5.5 what? Inches have been crossed out because they cancel. Inches divided by inches. Notice they're on top of one another. One's on numerator, one's denominator. When you're multiplying, those cancel out. And 66 divided by 12 gives us 5.5. Now we only have feet left, which is what we were looking for. So now we have, she must be 5.5. 5.5 is the same thing as 5.5 feet tall. So you're going to see that same setup where we multiply piece at a time to get what we need. Dula, an elephant at the San Diego Safari Park, weighs almost 3.2 tons. Convert her weight to pounds. Now, I put a snippet here so that we remember what the conversion is while we set this up. So she's 3.2 tons, and we want to convert that. So I already know that we're going to put tons on the bottom because that's going to cancel out. But I want to convert that to pounds. If I can go straight to pounds from tons, that's wonderful. And I can because I know that there's how many tons in a pound? There's 2,000 tons and, well, I did it backwards, didn't I? So there's 2,000 pounds. Good thing I looked up here in 1 ton. So now this equation tells me to do 3.2 times 2,000 divided by 1. Well, dividing by 1 is not necessary, right? Because we know we're going to get 1. So, but I will do 3.2 times 2,000. 6,400. 6,400 what? And that's really an important question is what do you, well, tons have canceled out and all I'm left with is pounds. So there you go. LBS. Pounds is a short way of writing that. Juliet is going to her family to their summer house. She will be away 9 weeks. Convert the time to minutes. Okay, I didn't put any up here because we're mostly familiar with this, and let's see if we can do this together. Well, and by we, I mean me, obviously. So let me start. So we got 9 weeks, and if I can get to weeks to minutes like in one move, that'd be great. But I don't know how to do that that quickly. So I'm gonna go piece at a time. So I'm gonna take out my weeks first, and let's take it to a unit that's smaller. So for 1 week, I know there's 7 days. Okay, so I know 7 days. And let's do days now. I got to get rid of my, so I cancel my weeks out. Now I'm working with days, but I don't want days. I want minutes. Well, let's see. In 1 day, do I know how many minutes? No, but I do know in 1 day there's 24 hours. Okay, so got that. I want to cancel out my hours though, because I want minutes. Well, can I get from hours to minutes? I sure can. I know that in 1 hour, there's 60 minutes. And see, so this is the blueprint that I need in order to go from weeks to minutes. Now, if you would have known already how many hours there are in a week, you could have skipped a step, or how many minutes there are in a week. It could have skipped, but I didn't. So I went piece at a time. I know how many days in a week, how many hours in a day, and how many minutes in an hour. I just realized I put 600. So let's do the math now to discover how many minutes are in 9 weeks. So this is going to be 9 times 7 times 24 times 60. So the calculator is going to do all the hard work. Actually, we did the hard work. The calculator is making it easy. Got the easy part. Times 24 times 60. Bam. That's a lot of minutes, right? So 90,720. But we expected there to be a lot, right? Because that's a pretty big chunk. 9 weeks. That must be quite a few minutes. But that's how you would do that conversion. How many fluid ounces are there in a gallon? So now we're dealing with volume. And I put the chart up here. Ounces in a gallon of milk. And sometimes I get confused between ounces in volume and ounces in weight. Because ounces in weight, there's a 1:16 ratio. And ounces in volume, there's a 1:8 ratio between cups, at least. So I know I'm going to need this one right here because we got ounces to cups, but we need gallons. So the other one I'm going to need is right here. I'm going to need gallons. But gallons go to quarts, okay? So I need the quarts. So I need to go from quarts to ounces, but I need to know how many quarts I have. So quarts to 2 pints. And how many pints are in an ounce? Well, so I'm going to probably need all of these conversions to get this set up properly. So let's get started. How many fluid ounces are there in 1 gallon? So 1 gallon, let's break that down. 1 gallon. Well, I know that in 1 gallon, there's 4 quarts. 4 quarts. I'm just going to abbreviate. And I know that let's see, how many quarts? How can I get rid of quarts? I know that in 1 quart, there's 2 pints. 1 quart, there's 2 pints. And getting rid of my pints, I know that 1 pint, there's 2 cups. 2 cups. So there it is. That's the unit I was looking for. And I can see that these cross out now, these gallons. So now if I multiply all this, I will get the answer I'm looking for. So what numbers I'm going to multiply? 1 times 4 times 2 times 2. 1 times 4 times 2 times 2. 16. So there are 16 cups in 1 gallon of milk. All right, so what about mixed units of measurement in the U.S. system? So for instance, this one. Charlie bought 3 steaks for a barbecue. Their weight were 14 ounces, 1 pound 2 ounces, and 1 pound 6 ounces. How many total pounds, so we want pounds, of steak did he buy? Well, we know 1 pound is 16 ounces. So there's a couple of ways you can do this. Let's add up all the pounds and then add up all the ounces. Then we'll convert those ounces back into pounds. So let's take the pounds first. Well, I'm just going to write it all out so we can see it. So we got their weights are 14 ounces. 14, I'm going to put OZ. That's the abbreviation for ounces. Don't ask me why. I believe it's another language. but you're going to see that for ounces. We also have 1 pound and 2 ounces. 1 pound. Ooh, I better not write pound as an LB here because it's going to look like an 11. So I'm gonna write 1 pound and 2 ounces. 2 ounces, and then 1 pound and 6 ounces. So we're going to add all this up. So I see that my pounds are easy, 1 plus 2. So I got 2 pounds here, and then I add up my ounces. I got 14, 6, and 2. That's 22 ounces. So I got pounds, 22 pounds and 22 ounces. So how many pounds is that? Well, I know every 16 ounces there's a pound. So I'm going to take 16 out of this 22. 22 minus 16. And that leaves me with 8. So I know that if I took one of those out, now I have another pound. So I'm going to make this 3 pounds and 8 ounces that were left. But they want the ounces in pounds. So I'm not going to even put ounces. So this is one way you can represent the answer is 3 pounds and 8 ounces. But if they really strictly wanted it just in pounds, what I would do is convert that 8 ounces to pounds by saying how many pounds is 8 ounces. I say 8 ounces divided by 16. Well, 8 is half of 16, so this is going to be 0.5. So I know this is going to turn into 3.5 pounds. So if that was a number that's kind of off, like 10, you could just take out your calculator and divide those two. So let's say if it was 10, we could just divide it with our calculator and say 10 divided by 16. And that'd be 3.625. So just know that if you got a different number, but that worked out perfectly, that was half. All right, so here's another one with that's mixed. Anthony bought 4 planks of wood, 6 feet 4 inches long. If the 4 planks are placed end to end, what's the total length of the wood? Now they didn't ask us which to put in, inches or feet, but think about it. When you have something this long, you know, you got 6 feet 4 inches, and you got 4 of these. Are you going to measure in inches or feet? Well, you're going to use the biggest measurement you can. So that's what we're going to do. We're not going to say it's 1,000 inches or whatever it is. We usually just take another measurement and use that. So I want to use, yes, we got 4 of these. So what is that? 4 times 6 is 24 feet. And 4 times 4 inches is 16 inches. Well, how many feet is that? Well, we got 24 feet. Well, what does this convert to? So if I took out 12 inches, I know 12 inches every foot. Now I'm going to take one of those and bring it over here to make it 25 feet. So, but I did 16 minus 12. So I took out one of these feet right here because 12 inches is a foot, and it left me with 4 inches. So we could say, what's the total length? 25 feet and 4 inches. And that's reasonable. But if they wanted it particularly all in feet, you need to convert these inches to feet by dividing by 12, just like we were to do when it was a bigger number. We 16 divided by 12. We got 1 and some fraction. So let's find out what that would be. And I'm pretty sure it's going to be 1/3 because there's 3 4s in 12. But let's do it anyway. So 4 divided by 12 is, there you go. So we got 25 and 1/3 feet. Or you can write 0.33 and put the little line on top. All right, make unit conversions in the metric system. Metric system is based on tens, as you see, multiplying by 10, dividing by 10. And it makes sense. Kilo is going to stand for your 1,000, hecto for 100, deca for 10, and the meter is just a 1. Deci again, going back again is at 10. Centi is 100. Milli is 1,000. So you're going to see that repeated as you work through these problems. Nick ran a 10-kilometer race. How many meters was that? Well, 10 kilometers, and I want to take the kilometers to meters. well, how many meters did he run? Well, there's 1,000. I'm sorry, I'm doing that backwards. There's 1,000 meters in a kilometer. So we can multiply this 10 times 1,000, and which is easy because you're just going to add a 0 because that decimal that's here, it gets moved over one spot, and there's a 0 there. So now this becomes 10,000. So the 10,000 what? Well, the kilometers cancel out. 10,000 meters. What about Eleanor's newborn baby weighed 3,200 grams? How many kilograms did the baby weigh? So we got 3,200 grams. And we're going to get rid of the grams and change those to kilograms. So see, I didn't even really think about this setup. I just kind of like, I know it's going to be this way. But what I will think about is what's the relationship between grams and kilograms? Well, there's 1,000 grams and 1 kilogram. So now I need to divide 3,200 times 1 divided by 1,000. So 3,200 divided by 1,000. 1,000. So really all we're going to do here, 3,200, there's a decimal here by 1,000. That means we're going to move this decimal 3 places. 1, 2, 3. That's going to become 3.2 kilograms. Now we've done that in another lesson, but I'll show you on the calculator just briefly. But I won't do it each time since we've gone over that. And I think it's pretty intuitive once you've done it enough times. So 3,200 divided by 1,000 gives you 3.2. All right, now let's convert. I'm going to use a different color, just tired of that color. 350 liters to kiloliters, 350 liters to kiloliters. So there's 1,000, 1, 2, 3 liters in 1 kiloliter. So again, I'm going to divide this by 1,000. Moving the decimal 1, 2, 3 places gives us 0.35 kiloliters. I want to make sure I write that. I almost wrote liters. All right, 4.1 liters to milliliters. So I know liters are going to cancel. I want milliliters. So how many milliliters in a liter? There's 1,000 for every 1 liter. So multiplying it by 1,000. So we're moving this to make it bigger. 1, 2, 3. So we should have 4, 1, so 0 and 0 there. 0, 0. Make sure 1, 2, 3. Yep. So 4,100 milliliters. All right, Rylan is 1.6 meters tall. His younger brother is 85 centimeters tall. How much taller is Rylan than his younger brother? So we need to put them in the same units, first of all, because he's been measured in meters, his brother's in centimeters. Let's change it to meters since either one would have been fine, but I'm going to change this to meters. So we're going to change 85 centimeters. We're going to change that to meters. So centimeters, meters. There's 1,000 centimeters in 1 meter. So we're dividing this 85 by 1,000. So it takes the decimal that's understood to be there, moving it how many spaces to the left? 1, 2, 3. Good. So 0.085 meters. Oh, sorry. I did that wrong. And you probably were trying to tell me. Why? Because centimeters is 100, not 1,000. I thought something was wrong with that. So we're dividing by 1, 2. 0.85 meters. There we go. So now that we have them both in the same units, we can subtract 1.60 minus 0.85. And that's going to give us maybe 75. Looks like. I don't want to guess on this. I'd just rather put it in the calculator. So I could do it by hand. 1.6, 0.85, 0.75. There we go. All right, Dina's recipe for a lentil soup calls for 150 milliliters. 150 milliliters of olive oil. Dina wants to triple the recipe. How many milliliters of olive oil will she need? So if you tripling, we're just going to multiply this by 3. gives us 450 milliliters. Is that what we want? Oh, they want liters. So we're going to take that 450 milliliters and convert the milliliters to liters. There's 1,000 milliliters in 1 liter. So we're really just dividing by 1,000, taking this decimal 1, 2, 3 spaces back, which gives us 0.45 liters. All right, lastly, we're going to go between the US system to the metric system, and then we'll do some temperature. All right, let me actually go back just to kind of glance a little bit more at these. So as you see, we got our inches to centimeters. These are the meters, are the I don't want to say European, but non-US metric. So those are, and we're converting from feet and yards and so on. So I'll pull up the ones we need on the problem, because those are kind of tough to remember since we don't have to do that a lot. But on groceries and produce, or not produce, but packaged items, especially volume, you'll see oftentimes both units. You'll see them in units of metric units and US units. Lee's water bottle holds 500 milliliters of water. 500 milliliters of water. How many fluid ounces? Okay, so we want to know how many fluid ounces are in the bottle. Can we go from milliliters to ounces? Let me check. So I see ounces here and milliliters. Yeah, so we can go straight there. Let's multiply milliliters, and we want to go to ounces. Notice I always set up my units first just to make sure I have the right plan. And now I'm going to ask myself, what do I know about these two units? Well, I know there's 30 milliliters and 1 fluid ounce. So now I can convert just multiplying it as it says. And as it looks on the screen, it's saying 500 times 1. 500 times 1, which I'm not going to do times 1 because we know what that is. But I'm going to divide it by 30. And it gives me 16 and 2/3, looks like. 16 point. And you could write it that way. Nobody wants to do 666, so I'll put another 6 on there. But you could also write it 16 and 2/3 ounces, because 0.66666 is the same thing as 2/3 of a fraction. So that's, and it didn't say round. Oh, yes, it did. I missed that part. So I'm going to say, if it said round, would have done that. And round to the nearest 10th. Nearest 10th place is right here. Not that it matters because they're all 6s. But we're going to look at this 6, look to the right, and it looks like I need to round up to 16.7 ounces. And there we go. And that's why I thought it was good to relook at the problem, which I usually do, just to make sure I'm answering the question after doing all that math work. All right, so Lel lives in Minnesota, but often travels to Canada for work. While driving on the Canadian highway, she passes a sign that says the next rest stop is in 100 kilometers. How many miles until the next rest stop? So round your answer to the nearest mile. So it's in 100 kilometers. I don't want to write all that out. So I'm just going to write kilometers like this. And I want miles. Can I go from kilometers to miles? So here's kilometers and here's miles. Yes, I can. Great. So here's miles. And I know there's 1.61 kilometers in 1 mile, according to this equation there, or conversion there. So we can now work that. Take out my calculator. I'm going to do 100 divided by 1.61, and they want us to round to the nearest what? Mile. So that means the whole mile. So we're going to say that's about 62 miles, because the next number over is a 1, which keeps this 2 the same. So it's 62. We're going to say it's approximately, we don't want to say it's equal, approximately 62 miles. All right, last but not least, Fahrenheit. We've got conversions and temperature. Fahrenheit and Celsius. Now, this is really interesting. Most of the time, we measure temperature in the U.S. with Fahrenheit. However, with liquids, we'll use Celsius. So sometimes, if you've been confused, if somebody said that's boiling point's 100 degrees, they were talking about Celsius, not Fahrenheit. But if it's 100 degrees outside, they're talking about Fahrenheit. So liquids are normally measured in Celsius, while the temperature outside is measured in Fahrenheit, at least in the U.S. In the Ukraine, where my wife is from, everything's metric, of course, and they use just Celsius. So she prefers to see everything in Celsius, and it looks crazy to me when I see what the number is, but she's used to that. So you'll see thermostats like this where you have both on there, Celsius on one side, Fahrenheit on the other side. All right, convert 50 degrees into Celsius. 50 degrees into Celsius. Now here's our equation here. We're not going to have the same setup. We're just going to have to plug this one in. So we got 50 degrees. So we want Celsius. We're going to say C equals 5 over 9. C stands for Celsius. 5/9. And we got Fahrenheit is 50 minus 32. So now this is just us solving this problem. 50 minus 32 is 18. So 18 times 5/9 equals our Celsius. And I can see that 18 divided by 9 is 2. And then 2 times 5 is 10. So I know it's going to be 10 degrees Celsius. But I'm going to go ahead and work that out so that you can see what I'm doing. 18, this is the same thing as 18 over 1. But what I was looking at this 18 and 9. So instead of going straight across and doing 18 times 5, so I could just do 18 times 5 and get 90. And then divide by 9 times 1, which is 9, and 10. I just saw that 18 divided by 9 was 2. So if I divide that by 9, that's 2. Divide this by 9, that's 1. So that leaves me with 5 times 2, which is 10. So I'm just showing you another way you can work this if you understand the properties of multiplication that we talked about recently. And I know that multiplication is commutative. So I can move this 18 over this 9. This is just a kind of a bonus here. I can move, instead of 5/9 over 18 over 1, I could say 18 over 9 times 5 over 1. And this goes to 2, and that makes it a lot easier. So our last problem would be here where, well, hold on, my daughter's here. Back now, sorry about that. All right, so bye-bye. The Fahrenheit. So we want to convert the temperature into Fahrenheit. So Fahrenheit is going to equal 9/5. And Celsius is going to be 20 plus 32. All right, so to get this one, we'll do 9/5 times 20. And again, I'm going to see the relationship between this 20 and this 5, because this is the same thing as 20 over 1. And I see 20 divided by 5. Well, 20 divided by 5 leaves me a 4 up top. 4 times 9 is 36. 36 plus 32 is 68. So I know that this is going to be 68 degrees Fahrenheit. But I feel like I need to work it anyway, just for anyone who didn't see that. So plus 32. So this would be 9 times 20. So if I just work it straight the way it says, 9 times 20, I don't need to multiply that. But I guess I'll do it anyway. 9 times 20 is 180. 180 divided by 5, because that's going to be 5 times 1 is 36, which is what we said. Plus 32 is 68. Plus 32, 68. So now we know it's going to be 68 degrees Fahrenheit. And there we have it. Did we do it all? So we make we did unit conversions in the U.S. system. We did them in the metric system, and we talked about how we can use those metric system and the U.S. system if they have mixed units, like we have pounds and ounces put together. We converted between the U.S. and metric system, and lastly, we converted between Fahrenheit and Celsius. So we did quite a bit. So great job hanging in there. Hope that made sense. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.